it will be hard
But
to.
can you just ask everybody, and based on that, can you just take, sir? Just for today's, sir, not because somebody. Because this topic I'm unable to understand. Like if you could take everybody's suggestions also.
Okay, guys, what do you think? Others.
Okay, sir. We can cooperate.
Sorry, what is the
So
question?
no problem, sir. We are comfortable on both the days.
Cooperate.
Yes, sir.
Okay, so you guys want tomorrow? What time then?
Evening time, sir.
See,
No,
evening
sir,
time-
morning.
No, so evening time, why it is not possible? Because that is other sessions are already occupied. So either I can take around 2 o'clock, 2 to 4 or something, or night after 10. Only that is the time, because in
2 to
between,
4 will be best, sir.
yeah, 4 to 6 some session will be there, because I don't know. When 6 to 8, then 8 to 10. So these time slots are already occupied with
Sir, 2 to 4. Sir, please continue this session, sir, because one day is already delayed.
Yes, sir. Please continue.
Yes, sir. Please continue.
You can cooperate with the recorded lecture.
Sir, because in
Okay,
the
sir. Okay, sir.
because in the coming days, I think we also have some revision sessions, so we will have to cope up
Yes,
with
sir.
that also.
Okay, sir.
So, actually, what I do, I mean, just, I'm not to take any reach to any conclusion, because some guys are saying no, some guys are saying yes. So, you guys have a date, or when is the last date for submitting this week 11 credit assignment?
30th of September.
30th.
Okay. So how many guys have issue with today's session? Can you please raise your hand? Otherwise, like what I can do
Could you
tomorrow.
kindly repeat the question?
I mean, how many guys have issue with today's session? Just from today.
So how many have issue?
Issue, yeah.
I don't have any issue with today's session, but timing can be 2 to 4 from the next times.
Okay, so 10 o'clock you guys are not comfortable. Just say, I just want to know your response. It's not like.
No issue right now. You can continue.
Sir, one thing we
Yes.
can do, sir, you can continue now, and if someone has any doubts, then they can ask you, or in the next sessions they can ask the doubts.
Yes, sir.
We can
In the
continue now.
Next upcoming sessions.
Yes, sir.
Yeah, actually,
No
thing is that-
problem, sir. Just ask.
Yeah, so
They
people
wrote their
have-
doubt on any pages, and then after the upcoming lectures, they can ask you doubt.
Okay, because see, people have already joined the session, and they have already made a mind of be in the session for at least 1 hour. 1 hour is okay for you guys, no? At least.
Yes.
Yes, sir.
Yes, sir.
Yes, sir, we can stay up to any time, sir. No problem.
Yes, sir.
Okay, great. So Dhanya, no? Dhanya, she left. Yeah, Dhanya is here. What do you say, Dhanya?
Yes, sir. No problem. No problem, sir. I just, if everybody's okay, then I will also just manage.
Okay, because thing is that people have already come, no? So I mean that's
Yes, sir. No, sir. I'm just saying everybody is. That means then I will not disturb, sir.
okay, great. So today plan is that I will take. So I will just give you the summary of recursion, and then DFS, how it works, how the code, what sir has explained. So you guys have, I assume that you guys have already watched that lecture.
Yes,
Where
sir.
sir has explained
Yes,
the
sir.
code.
Yes, sir.
And also.
But have some doubts from lecture codes.
Yeah, okay. So that's why, like the DFS one.
Yes, sir. DFS one, and one more list recursion sorting. That one.
Okay. So also I think on Monday I think Soham has taken that Solvit instructor session. On the
Yes, sir.
he has explained DFS one. How many you guys have watched that lecture, DFS one? So what I do, I just take that problem, that particular problem, and then I will try to explain the DFS how it works actually, that line by line. Okay, so not wasting time, just start and
Excuse me, sir.
yeah, hi. Yeah, tell me.
Hi, there will be an overview of graphs also, right? In this session?
Yeah. So graph, what do you want to know? Because last lecture I have talked about the graph, I mean, so what type of graph, directed, undirected, then weighted
Oh,
graph.
you talked about it already.
Yes. Okay.
Okay.
Okay. So my screen is visible.
Yes, sir.
Yes.
Yes, sir.
Yes.
And
Yes, sir.
I
Yes,
assume
sir.
that these slides you have already watched. I mean, you have
Yes, sir.
already.
In week 12.
Yeah. So that is all the revision session. I will just going through that one, but I will talk about the key points of that slide. Okay. So,
Sorry to interrupt, but your voice is somewhat low.
is it?
No, sir. It is good.
No, sir, it's
all right.
Fine.
I mean, so those who are not talking, please mute yourself, and then it might be clear. No, still it is not clear. I think.
So
What
now
about
it's
what about now? Is it?
Fine, sir.
yes, sir. Fine, sir.
Yeah. Okay. So okay, just a minute. Just give me a second. Or should I continue with this? Yeah, fine. Yeah, my screen is visible, no?
Yes, sir.
Yes, sir. Yes, sir.
Yeah.
Yes.
Yeah. So yeah. So so in week 11, okay. So if you have any doubt, you can stop me, but just give me 1 or 2 minutes to explain. Little bit talk about the recursion. What is recursion? Why it is required? Yeah. So in week 11, sir has talked about the recursion, and recursion. First of all, we need to understand that what is recursion. So recursion, to understand the recursion, you might have studied this one procedure. You guys have already studied procedures?
Yes, sir.
No? Okay.
Sir.
Yeah. So
Yes, sir.
the why means what is the meaning of recursion is that, like, if you, so generally what you are doing, like if any procedure is there, let us say procedure something, uh, let us say do something, okay?
Get something.
Do something, and you have called this procedure, and with some variables like a comma b, two. So these are the two parameters for this, no? And you are doing something in this, and then what you're doing, int, sorry, int do something, है ना? So that is what you are doing. Control C, Control V. I mean, obviously you will have some return value here, okay? You will have some return value, let us say x or something, whatever, or x comma y. Understand?
Yes, sir.
So how we will call this procedure? Since you will have to return like this, no? Remember? I mean, how will we?
Yes, sir.
Yeah. So let us say, I mean, p comma q, and you are calling procedure do something like this. This is the general case I'm talking about. Okay. So you have called with two arguments, and that is as soon as you call this guy, it will go here. So this is, let us consider this is one of the code you have. You have one code where one procedure is called do something. So as soon as you will call with the two values, it will check where is the do something procedure. So it will come here, it will do all these things and it will return, and the value of x will be stored in p and value of y will be stored in y. Or okay, or
So P and Q should also be in list, no?
I don't think so. Okay, so so what it is happening? You are calling one time this one, and as soon as it is done, it is completed the return value. So the whole code will be completed. What if in some case, I mean, now this is the general case. Now you are calling this procedure inside itself with something. I mean, let us say you are having let us say some value x, or let us say t, and you are calling this guy itself do something with some, obviously you have to use two variables, so some like a1 comma b1. So what you have done, you have called this procedure within itself. Can you see the difference now?
Yes, sir.
Here you have called one time. Okay. Now you have come here, and as soon as you are doing something, and here again you have called. So as soon as you have called this guy, where it will go? Again, it will start from here. It will do all these things. Then again, it will come here and it will keep going, and it will keep going. I will tell you when it will stop. That is the another case. But it will, what you have done, you have called same procedure within itself. So that's why this is called recursion, recursive. I mean, you are calling within itself the procedure itself. Understand? So also you can, do you remember something called nested iteration? Understand? Nested iteration,
Yes, sir.
do you remember? So what you are doing?
Yes, sir.
Loop inside loop. So here procedure inside procedure at the same procedure itself. Can you see this? If that is the different procedure, like you might have also seen some code where you have called with a different procedure, but here is not the case. You have called same procedure within itself. Can you see the difference? How it is being different from the other cases what I have talked just now? I mean, you might have seen like nested loop, where the loop is like you are calling, and again it is starting from different. That is a nested loop, not a recursion. Another thing is that like you have one procedure, it might have do something one, another something called evaluate something. That is not a recursion. Recursion means you have called the same procedure within itself. Therefore, this is called recursively. I mean, recursion. So did you understand what is recursion?
Yes, sir.
I mean, what is recursive call
So
actually?
can you just explain again, sir? You can just calling the procedure.
So
Sir,
recursive,
we can say recursion as repetition.
it is the repetition, but loop is also a repetition. While loop, what we do, we generally repeat a procedure, repeat a flow of code, or whatever the statements which is inside the loop. We do the same thing, but that is not the recursion. Recursion is that you have called the same procedure within itself.
So, sir, repetition of the same procedure within the procedure mentioned.
Yes. That way you can say. Yeah. Okay.
Sir, if we assign one value t with this procedure, so it will work as a procedure again, sir?
Can you repeat, please? I couldn't hear it.
Here we are assigning t equal to do something a1 comma b1. No, sir.
Yes.
So this is
yeah. Please.
Something is the procedure. This value is assigned to t.
Yeah, means what it will happen, like as you have called this, see, as initial how it will start. So it will start like this. You have a and b, and as soon as if you see do something, it will come here with the two values. It will come here. Now it will see again do something. So again, it will not go further. It will start from here itself.
Sir, can you explain it with a simple example, sir?
Yeah, so just I was talking about here like how recursion is different from others. I will talk you in some with example, then it will be more clear. So I will give you some example, but the main funda I was trying to say is that recursion means you are calling the same procedure within itself. That part is clear for everyone.
Yes, sir.
Okay, so yeah.
Yes,
So
sir.
is it like how we find factorial of a number?
Yeah, so I will come to that, but yeah, so true, that is the case. But this funda is clear for everyone. Then I move to the next thing.
Yes, sir.
Okay.
Yes.
Okay. So I will give the example how it step by step it works. Nikhil, can you please mute yourself? Yeah. Okay. So now, so thing is that like recursion means you have called the same procedure within itself. Means you calling a procedure, same procedure, calling same procedure within itself. Okay. Now come here. Next thing. So next thing is that like so here I mean, so to create a procedure, I mean, there is a essential thing. So if you are keep calling a procedure, I mean, for how many times it should call this procedure? There should be some termination condition. I mean, like the loop means when you are writing the loop, like what do you do? Like while I is less than some number, let us say 10. So wherever that I is becoming I, sorry, I plus 1, I mean, how many times it will run? I mean, how many times it will run?
Sir, what is
Until the
I?
condition is not broken.
Yeah.
So 9
So,
times.
I is equal to 10. I is equal to 0. So it will run for how many times?
10 times.
9.
0 to 9.
9 times. 9.
10 times or 9 times?
9.
10 times.
10 times.
Why?
10
Because
times,
it is a starting with 0. So can you see that there is a termination condition? It will obviously it will repeat the same thing. Whatever the expressions are inside the loop, it will do it how many times? That answer will give this condition. Means it will run for 10 times. Understand? So that is in case of recursion, to terminate the or to stop the calling of the same procedure, that is called what? Base case. Base case actually is nothing but stop the iteration or stop the calling the same procedure. So to write a recursive procedure, I mean, you should have base condition, and the second one is what? The
Inductive.
the expression through which or the condition through which you are calling the same procedure is called inductive case.
Inductive means calling itself.
For that, through that you are calling. This is like inductive case. Somewhere it will stop. So inductive case. So I will tell you in much more details. Just give me a second. Or inductive state. I mean, if I'm writing the. So to write the recursion, you need two things.
Sir, recursion reduces the pseudo-codes.
I tell you. Just give me a second. Yeah. So the two conditions should be there. Then you will be able to write a recursive procedure for a I mean, for any, problem. I mean, problem in the sense, see, these are the pseudocode. Pseudocode is nothing but you are writing to solve a problem itself. I mean, see, means if I'm asking the how many students are there in class, you are solving a problem. You are giving answer to that particular question. So the recursion procedure, I mean, you can answer most of the question, but not all. And what are the condition to write a recursive procedure? You need two things: a base condition to stop, or simply for stopping the procedure call and this is the for calling the procedure, है ना?
Yes, sir.
For calling the procedure. ठीक है? That's clear to everyone?
Yes, sir.
Okay.
Yes,
So,
sir.
Yes,
and
sir.
so yeah, so recursion, what it does, no? I mean, sometimes, I mean, so recursion, why we
Sir,
write?
the
Yeah.
first thing at the end, can you just explain how did you explain recursion? So the procedure do something and all that.
Which one? This one. This
Yes,
is
sir.
just I mean, I just told that what is recursion. Why the name, we have a special name we have already given, because we are not writing anything. What we are new anything, because we know the procedure,
Yes, sir.
we already. Why the recursion word came, and why what is the need to write or define some different new quantity? So that is what I was trying to call, that we know already procedure. What is procedure? So in this case, we call the procedure same procedure within itself. And this, whenever this situation occurs, or this situation, if you want to write, that is called recursion. That's all. The definition I was trying to say that while writing this one. Okay.
Sir, can you just explain a base condition?
Base condition, I tell you. I mean, see, so in case of this loop, just give me also 1 minute, and after that you can ask. Yeah, I'm repeating actually. So, recursion. So generally in loop, what you are doing actually. So if this is like how many times this loop will run? I mean, how many times this code will work? How many times?
Infinitely.
Everybody agree on this?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes,
here
sir.
also, like in this case, recursion, it shouldn't, if there is no any termination condition, it will run for infinite time. So to stop the iterative, I mean, so up to a limit where we need a loop, what we do, we give a termination condition. So this is called a stopping a procedure. Means it will run till where, how many times? Till 9th step run. When it reaches to the 10th, it will stop. So to the same thing to doing in the recursion, something called base condition is required for a stopping the procedure call.
Yes, sir.
Understood now? And inductive is like you are calling the same thing. Like here it's like I is equal to I plus 1. So you're actually calling this loop again and again. Hai na?
Yes, sir.
Okay. Clear?
Yes,
Okay.
sir. Clear.
Yeah. So now I give you some example. I mean, example, I mean, it's already there. I will recursion. So see, recursion is a procedure in which a procedure calls itself. That definition is clear?
Yes,
All
sir.
Yes, sir.
all problems cannot be solved using recursion. Why? Did I give the answer for this question? No? Yes or no? What are the two important things we need to have for writing a recursive procedure, recursion?
Sir, a base step and a inductive step.
So inductive step you can find, but the most important is the base condition. So it's not like that if you want to invent a new thing, and it will keep going there. I mean, so that's why, like, you invent something, but it should stop at some time, at some point of time. So that's why, like, you cannot write all problems using recursions. You can use a simple code where you will use the loops and other procedures, but you
Can you
cannot.
give some example of this?
Okay, so only when I come to I mean, example of this factorial, then I will take. Okay, yeah, only problems with have a base condition can be solved using recursion. Yeah, recursion simplifies the pseudo-code. It simplifies, means it makes it clear, but means recursion, to use a recursion type of method, it actually needs a little bit more brain compared to writing a simple. I mean, I will tell you how. I mean, so this I can explain with this one. So this you can see that, no? I mean, What is this procedure to find a factorial of a number? So what do you mean by factorial? Everybody understand what is factorial?
Yes, sir.
Everyone is
Yes,
from
sir.
math background.
Yes, sir.
What is
Yes.
factorial? What is factorial 0?
In
Or
a
how
statement, there is
One.
also
factorial
One.
0 is?
One.
one.
Factorial 1 is?
One.
One.
Okay. Yeah. So factorial means, I mean, if I write like factorial 5, so it is like
120. 5
yeah,
into 4 into 3 into
1
1.
to
120.
yeah. How should I? 1 into 2 into 3 into 4 into 5. So it will be like 120. Okay. Chalo. So like that is like so what you have done actually is you have written n in, if it is if you want to generalize, let us say if you have a n factorial, what you will write, how you will write, it will start from
N into n minus
1
1.
N to N.
1 2 3 till where?
Order n.
N,
N.
sir.
I mean you can write like this, I mean n minus 1 star, sorry, star n, like this. You can write it like this also. It will,
Yes, sir.
is it
Yes.
both are same case?
Yes.
Yes, sir.
Sir, n minus.
Hmm?
N minus 1 is missing.
N into n minus 1.
Oh, sorry, I missed it. 2 is 2 1. Okay.
Yes, sir.
Yeah. So I mean, so without using recursion, you can have what you have done. You have defined a procedure called factorial, in which you have n. N is the like what parameters through which, or the arguments through which we have called the procedure factorial. So what it is actually doing? Fact, initialize some variable, initialize as a 1, and then while n is greater than 0. So it will be keep going, fact and fact into n. It will keep going and it is reducing by 1. N is equal to n minus 1. It will go till when n becomes 1, till when, no? I mean, how it is happening, how it is working. This procedure is clear for everyone? Yes, or no?
Yes, sir.
So what?
Yes, sir.
Initially n is 5.
N is a factorial number to which you have to find the factorial.
Yeah. So if n is 5 means I want to know the what is the factorial value of 5. Okay, miss. If so, the question is like what I do. Means I need, let us say 5 factorial. I want this one. What is the value of this one? So what I have done, I have called value something. I mean, value is equal to what I have done. I have called this guy factorial with number 5, like that. So as soon as if you see 5, so you will go to the factorial procedure, and you will have n is equal to 5, and it will keep going that till n is becoming 1. Means when it is 0, it will stop the loop. Can you see this? It will stop the loop. Hai?
Yes, sir.
So this is pretty straightforward, but how we can write in recursion? I mean, so see, recursion is what do you want to have? I mean, using recursion, I mean, you need what? Two things: the base condition
And inductive.
Inductive step.
Base condition should be what? When it should stop. I mean, if
when the n is equals to 0.
yeah, because see, n should always decrease. That's a sure. I mean, this is like same. I mean, n should decrease, but till when? because till when factorial is defined, factor -1 factorial is defined.
Not defined.
No, sir.
Not defined. So means
So,
you
sir,
can go till here.
sir,
Huh?
there should be an extra condition na, that n must strictly greater than 0.
Yeah,
Because
yeah.
then it will not terminate.
Yeah, so yeah. I mean, so because n is here really understood.
Sir,
I mean,
after writing the procedure of factorial, we have to start calling this symbols. Sir.
Sorry.
So after writing the procedure, then this is the. So I'm not understanding the difference between the two.
So you cannot see the difference between two.
So in the code, I'm able to understand, sir, but how it is processed.
Yeah, so that is what I'm going to explain. No, I haven't explained till now. So so that you understand. So using recursion, if you need to use recursion to find the factorial of a number, you should have base condition, and you have to figure out what should be the base condition for the given case if you want to use. Like here is the case. I'm trying to find that this is not defined. So you should be calling the same procedure. I mean the same procedure till when it is n is equal to 1. Once it is becoming n is equal to 0, you should stop the procedure, because after that you are not supposed to call, because there is no meaning after that, because you cannot have a factorial -1. Anna? So this should, when n is becoming 0, you should stop them, and you should stop the call. Anna? So how it will work, I tell you. I mean, so simply procedure factorial. Now factorial is having a recursion. I mean, and what if n is, I mean, if I want to n is equal to 0. Someone was saying it should be n greater than 0. So I tell you what will be the I mean, so what will be the error it will come, I tell you. Else, I think these things are all already with you, so I think if I'm not writing also, it should be okay, no? But yeah, let me write that still for one case, and then, because to understand the DFS, you should be knowing this recursion. So that's why I'm trying to at least make you understand with one example. Then, yeah. So how it will work? Oh, okay. So I bring all this case in one page, so then it will be better. Yeah. So this is with one example, and you have to close this guy and then end factorial. Anna? So how it will work, I tell you. I mean, so I think it's explained in pretty straightforward. Yeah. So I mean, when you have called, so let us see, you have answer means how step by step it will work. So just give me attention here. I mean, how it will work. I mean, so you have a. So let us say the value. I mean, if you want to know the value. So value, how you have called factorial, and n is equal to 5. Okay. Agree? So as soon as if you see that, where it will go, I mean, let me control, I mean, this whole
Go
thing
to
should
else
be
part.
there. Let me write here itself. This one here. So factorial is there. So you have called this guy, and finally the value, means factorial value should store here in the value. So as soon as you have called this one, where you are looking for factorial, so factorial here it will go. So this is the same one main code. I mean, this is, sorry, this is one of the code, actually main code, total code. I mean, you can say that this is the single
Can
code.
you just explain this again?
This is one code you are having. I mean, if you want n is equal to,
Sir, sir, I know everything. How do we get n minus 1? So
I tell you. Just
Keep
to understand this, first to understand, this is actually one code. Actually, you have, okay, you have this one code. So what you have done, you want to know the factorial of 5. So as soon as if you see the factorial 5, it will come here, and how it will work this one. So n is equal to 5, so n will become here 5. Just agree? Whatever the value you have, that will be stored to the this parameter of this procedure, no? Agree, everyone? Now it will check
Yes, sir.
if n is 5 or not. If n is 5, 5 is equal to 0. It's true or false?
False.
False.
False. It will not go. Where it will go? It will go to
Else.
the else
False.
block.
Else part.
And else block. So I write here value is equal to factorial
5 into 4 factorial.
factorial 5 initially. So the return value will come here. How it will come? I tell you. So now this is here. So it will go to the else block. What it will return? N
5 into 4 factorial.
minus 1. So wait, sorry. So it will be like value, same thing. I can write here. Yeah. So this is your becoming n star factorial with n minus 1. Can you see this?
So
Factorial
4.
n minus 1. है ना?
Yes, sir.
n minus 1, 5 minus 1 is what?
4.
4.
So you have called now again this guy with what? So n was actually 5. So let me write 5 into control C. Just give me a second, then I will explain you. So it will be now 4. Now, can you see this? I mean, again, this term, the return value, which came here, again have this guy. Can you see this? Factorial. So as soon as this factorial is there, again it will come here. It will check n is what? 4. 4 is what? 4 is equal to 0. No. Again it will be a return, and this return will be n into factorial n minus 1. So what is the n value when you have this one? N is equal to 4.
4.
No?
Yes,
This
sir.
will be replaced by what? Again, this will be n into. So n into what? 4. 4 into this will be
3
n minus
factorial.
n minus 1. N minus 1 will be what? 3.
3 factorial.
Now again, this is what?
4 minus
Again,
Factorial 3.
n will be 3, and 3 is equal to 0. No. Else part it will go, and what will be? N into n minus 1. So this will be 3 into what? 3 minus 1 will be what?
2.
2.
Again it will, so again factorial term is there. So again you have called this guy. Again n will be 2. Now 2 is equal to 0. It's true or false? False. Again it will go to the return block, else block, where it will return n into. So n is what? 2.
2.
And 2 into n minus 1. N minus 1 is what?
1.
1. Now again factorial 1 is there. Now again it will go 1. So 1 is equal to 0. True or false?
True.
False, sir.
False.
It will go to the else block. Again it will return
N
n
into
into
n.
n minus 1. So n is what? 1.
1 into 0 factorial.
1 into
0
1 minus
factorial.
1. 1 minus 1 is what?
0.
0. Again this guy is called. Again it will come here. N is 0. 0 is equal to 0. It's true or false?
True.
True.
True. What it is returning?
1.
1.
The value of this one is what?
1.
1.
1.
What is the value here?
120.
120.
Did you just understand how it is happening? One more time.
Yes, sir.
One more time.
Yes.
So as soon as this guy n had 5, it is there. As soon as if you go inside, not of 0, it will go to the else block. What it will return? N into factorial n minus 1. So n was 5 initially. So 5 into 5 minus 1, which is 5 minus 1 is 4. So 5 into factorial 4. Again it will go here. 4 is not a 0. It will go to else block. Then again 4 into factorial 3. Again it will keep going till n is equal to 0. For 0 case, this is true. It is returning 1. So can you see this? The last case, this is where you are not calling the procedure. You are returning a value. You are not calling a procedure. Did you understand? Whereas this was what you are calling a procedure itself. So in else block, this is what you have inductive step, whereas in this is a your termination
Okay.
for what base condition. So can
Base
you
condition.
make a difference here? Which is the base and which is the inductive step?
Yes.
Yes,
sir.
sir.
So inductive
can you
step,
please
here you are
explain?
calling the
Sorry,
procedure.
sir, can you just explain the base and the inductive step?
Sorry,
Base and the inductive step.
base and
The
Inductive.
inductive step.
so this is inductive step. You are calling the procedure in inductive step. So what I have already mentioned, but again I'm mentioning that in inductive step you are calling the procedure itself with some changes, with the some change. What you have made change? You have n into you have reduced some value. It will depend according to your need. But in case of base condition, you are returning a value, not a procedure. Can you see this?
Yes, sir.
Guys, yes or no?
Yes, sir.
This is the difference you have. You are in case of base, you are returning a value, whereas in case of inductive step, you are returning a procedure itself with some value. Means obviously some combination. How it works? Did you understand? So the same thing it is explained here. I mean, can you see this? This is
Yes, sir.
Hannah?
Yes, sir.
Yes, sir. So how long is this class for? Sorry.
Sorry, how long it will?
Is this class for, sir?
After that I will explain DFS and then questions I will take then tomorrow. Then I mean just today the revision session and then tomorrow you revise things and then I will take a question based. So what do you do? Those who wanted to leave the session currently can leave, but try to watch the whole lecture before tomorrow session. If I'm keeping tomorrow session sometimes, or if it is
Tomorrow in what time,
the
sir?
slots,
Tomorrow in what time, sir?
I mean, it will be mostly in daytime, 2 to 4, or if it is not, then Sunday will be maximum. The 2 days I'm just keeping, any one of the day I can keep 2 to 4 daytime, because I
Okay,
can
sir.
understand that people are struggling to be awake till 11 or 12. I mean, will have a different, but I'm sorry because I'm just conducting session with the off time. I'm sorry.
So like in these lectures, if you have any doubts, when can we contact you, sir?
Tomorrow or day after tomorrow I will have a, so today so for everyone I'm just saying that after that I will talk about the DFS, how it works, and the code also, the DFS code, and then tomorrow I will be taking the questions. So this is the agenda for today's session. After that I will stop because people have another things to study because they have a exam on other things, so they want to sleep. So I don't
Sir,
want to.
have you already completed BFS in the previous lecture, or you will be doing
No.
it
So I'm
after this?
going to explain now.
No, sir. BFS, breadth
No,
for search.
DFS is just I will talk about the how it is different from DFS, but we are not focusing on DFS. We do not ask any questions, anything. Since we are talking about DFS, which is important for our lecture and upcoming courses or wherever some model or anything. That's why we are teaching here DFS. BFS we are not much bothering about here, but I can tell you the difference. That's all. But only I will talk about mostly in.
But sir, there were many
DFS.
questions in the assignments from BFS.
BFS I
Yes,
might
sir.
have, so I might have asked like just if you go through, if you do BFS search, then what is the path like that. I haven't asked.
Yeah,
too
like
much
there
in-
was a comparison between the DFS and the BFS, and like the comparison of the results between the two.
so that is there. That's how you were transverse through the tree. That is the question might have asked in activity or somewhere. No, I don't think so much more detail I have asked in BFS. Okay. Yeah.
Yes, sir.
Yeah. So I mean, now somewhat this is clear, or should I give? I mean, do you want to write some code here, or should I give you some more example on?
Sir, there was a example in the question of sorting a list. That can you explain that? one more example. If you want to take that example.
Yeah, if you want to, I mean, just like just give you one example question. I mean, to find the maximum from the given. I mean, this question might have already discussed. I think no, to find the maximum or the largest number from in a given list. You guys have written the code
Yes, I guess.
using the recursion as well.
Yes, I guess.
No, I guess no. Did you write or not? I mean, others. So this is the HW for the guys. Tomorrow I will talk about those who haven't tried. Please write. So I'm just writing a question. I mean, if you have any doubt in the recursion, you can ask now. So write a
Will you also
pseudo-code.
be discussing questions today?
No. So questions I will be taking tomorrow because I am considering the others who are just going to drop the session. So tomorrow I will have a session for the question based. I mean, today just concepts. So write a pseudo code for finding the largest number given in a list. So first question will be what? Without recursion. And second one is the with recursion. Okay. Question is clear for everyone. So try to write. So you should be understanding that when should you stop. So you shouldn't. So I just give you a hint. I mean, so you need a base condition. And base condition means when you should stop comparing and how we'll do comparison. That you have to understand that. So please write this one. I will talk about tomorrow. This one I will.
Sir, this question you had already given in the TA session, no?
Yeah. So everybody had done.
Sir, without recursion is done. With recursion was
pending.
Yes, sir.
I will discuss tomorrow then. Yeah. So you guys want some more clarification regarding recursion or
No, sir.
So just one question regarding this 5 factorial.
Tell me, please.
So the last step when n is equal to 0, we are returning the value 1 to the else block.
No, not else block. We are returning from f block itself. No, 1. So where it will come? It will come here. Hai.
But the procedure will have only one return function, right? It can return just one value.
Yeah. It is returning quantity 1, the number, the integer 1. Whenever n is becoming 0,
yes,
it is returning 1. When other than that, it is returning this n into factorial n minus 1.
Yeah, I understood up to 5 into 4, 3 up to 1 factorial. But when n is.
So when, see, when n was becoming what? This was the case, no? Factorial
1.
Factorial 1. What was the what is happening here then? When n is 1, then it will come here. N is 1 is equal to 0. No. Where it will go?
Else block.
Else block. So n into. So n means what? 1 into
factorial of 0.
Yeah. Now again factorial 0 means again it will come here.
Yes.
N is 0. N is equal to 0, 0. Is true or false?
True.
So what is the value of this one? Return value. Because you have called this one. I mean, so what you have done? You have called factorial 0. N is equal to 0. So n is equal to 0. It will come here. It will not go to the else block because this is true, no? So it will come and the return from here itself, it will return. Further, there will be no reading of next one. So it will be like it is returning with the value, integer value 1. Okay?
Sir, can you show the same procedure without recursion? Perfect. 5 factorial.
Yeah, this is the case, no? I mean, it's a clear. I mean, this is the case, no? what you are doing actually, you have defined a variable integer type data type 1, and let us say 5. 5 is greater than 0. Yeah. What is the value of fact then? Fact is equal to 1 into what is the value of n? 5. So 1 into 5. So how you can see that how it is changing. So fact will be sorry, yeah. Fact will be here 1 into what? 5. Then again next time n is becoming 4. This is a closing loop of this one. So again it will check 4 is greater than 0 is true or false?
True.
True. So it will come inside and fact will become fact. So fact is this one. 5 into 1 is 5. So I'm just keeping for the timing. And into what? 4? Correct, no? And
yes,
n is becoming what? 3.
3.
Again 3 is greater than 0. Again it will fact will be into 3. Correct, no? Now 3 is becoming 2 and this is like 1, and then n is becoming what? 1 minus 1, 0.
1.
This is greater than 0. Is true or false?
False.
False. It will. So you have stopped the iteration. Where it will come? It will return the fact. What is the value of fact you are having right now?
So in this also the procedure is calling itself, no, in this one also.
This is not a procedure. No, what you are iterating within a loop. You are not calling the procedure. You are running within the. If you are calling the procedure, means it should start with the n is equal to the some different value. You have reinitialized the fact is equal to 1, and then it is doing like this. You haven't called the factorial procedure. You are running within the loop itself. This is the difference between the loop and recursion. It's clear? No? Still no? What's your name?
Sunita.
Yeah, Sunita. So did you understand? So you are calling this is a loop you are calling. Here you are calling what? Factorial. So factorial is a start n minus 1. So it is coming here, and then again it is checking here. Understand?
Okay.
From here. Here it is like within here. Okay?
Okay.
Okay. So now I just try to talk about the DFS. Depth first search.
Sir,
Yeah, tell me.
I was saying if in the code, in the procedure, if you can add a question that n greater than 0.
So n greater than 0. He is saying that it should be like n greater than 0.
No, sir, not here.
Where?
In above this n line, that if n is less than 0.
Where should I write?
After procedure factorial n, if we can add an condition, if n is less than 0, then
here,
return
below that.
No, sir. Here procedure PROC factorial n.
Where? I mean.
So the second line from the
yes, sir.
top.
Second line.
Here, below that.
No, below PROC.
Okay.
Yes, sir. If after this we can write if n is less than 0, then return not defined. Then it can work for negative numbers as well, na?
Yes. Yes. True.
Otherwise, if we will give negative input, then it will not work.
Yeah. Means see, thing is that like I mean here we have already see, we already assumed that n should be a positive integer. I mean till 0 you can also put, because 0 is not a positive integer, but n shouldn't be negative integer. So that's why if it is n negative, if you see, that's why I'm telling that you can always, there is always chance of improving the code. So now you are, so this is like this code, when this case is not there, this is only valid for when you are entering the value n is not a negative number. Means n start for 0 to infinity. But what if someone is like very unknown, don't know anything, is by mistake he has put n is equal to -5. So it will not, code will not run. But there should be some answer. A code should also understand what this guy is making mistake. So for that case, you can simply write here, I mean, return also the print or something, whatever print function we haven't defined, but you can have a here return. What you should write?
Different return.
Return not defined, है ना?
Yes, sir.
है ना? And this is the case. ठीक है? Now this is valid for every integer value. Clear?
Yes, sir.
Okay, good.
And sir, why we needed recursion when we can do this simple step?
So this is for here. It is like looks like both are having. Sorry, yeah. Here it looks like both are having same number of lines in steps, but there are some cases where very long codes are there. If you use a recursion, it just simplify. I mean, it just reduces the length of the code. But again, the same time, to use a recursion, you need to put extra brain. I mean, because it's not an easy
Sir, can
task.
you show one example like that in the end?
Currently, I'm not getting. I mean, but somewhere some example is there. I mean, simple code like in the exam activity question, I have also mentioned that sum of n integers numbers. There also you can write with the simple as well as for using the recursion as well.
Like you have given a question, write a pseudocode for
yeah,
finding largest
this
number.
one you try. I mean, I think
With recursion and without recursion, if it can happen both the ways, then why?
I mean, so that's why no see some I tell you, Mr. Currently I do not have the correct example, so where I can show you, because the big code and the using the recursive, it will make it small. Currently maybe tomorrow I will have that one. I will
Okay, sir.
come up with that one. But I try to do this one, how it is different. It is coming. I don't know, Miss. I haven't read, but surely it will be. You are going to get answer with recursion as well. But see how whether length is decreasing or not. Just we have to check. Okay.
Okay, sir.
Okay. Yeah. So next is like the important topic is DFS, depth first search. So there is like these are the like techniques. I mean, techniques to reach the sum of the nodes. I mean, so nodes in the sense, see, in graph theory, I have already talked about the what are these? These are the nodes and these are the
edges.
edges. This can be directed or undirected. So for the timing, I have taken without a direction. So this is like undirected or click, you can say. So to reach some point or some to reach from one node to another node, there is a like traversal, means you are traveling through the means how you can reach to the tree. So there are methods. Methods are, some of the methods are called DFS, depth first search. Another one is called breadth first search. So if you might have solved that activity questions where you can clearly understand that what is the depth first search. So depth first search means, as like if I say that you start from the node 1 and what are the neighbors? Yeah, 2 and 4, and obviously in this DFS you should be starting with the next node will be obviously 2, which is a smaller in the magnitude. Generally this is the rule we are following, I mean, generally. So once you start with 1, the next neighbors you have 2 and 4, which you can have the magnitude minimum is 2. So after 1 you have to reach at the 2 in case of depth first search. So what in the depth first search means picking one point and you try to reach at the last position through that depth. You should be going through the depth. You should be not broaden your legs in the sense, I mean, you have to just explore till the last, means how much maximum length you should be going through the depth. Whereas in breadth first search, you should be reaching to the all neighbors. I tell you that some examples are there. Where is that? I just if you give, I think this is the one. Yeah, this is the case. Depth first search and breadth first search. So
Yes,
can you see that this is the tree you are having? Just give me attention. So the first question itself, like starting from the node A. So this is the root of the node or the origin of the tree. Which algorithm visits the least number of nodes before visiting node D? So where is node D? Here. So my screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. What about now?
Yes, sir.
More visual. Okay. Now somewhat it is clear, na?
Yes,
I mean,
yes, sir.
yeah.
It's better.
Yes. So in case, so the question was that if you want to reach the node D, so what the two methods, the two techniques are there, DFS and something called breadth first search, BFS. So which techniques or through which method you should be having the less number of nodes before reaching to node D? So let us see. So in depth first search, what I told you, I just tell you how it will work. So you have to start from the A. This is the origin already given. I'm just hearing background noise. Can you please mute yourself, guys? Yes, thank you. If you have any doubt, you stop me. Otherwise, you can mute. Yeah. So A is there. After that, you have to see the neighbors. Okay. So neighbors are here. Which are the neighbors? B and C. So in B and C, you can have something is given, some instructions are given. I think if it is not, then yeah, assume that if there is a choice multiple nodes, algorithm will choose the node which comes alphabetically first. This makes sense. Means whichever, like if you have D and G, which one you should choose? B, which comes alphabetically first. If it is not given, you are supposed to choose anything. Okay.
Yes, sir.
Okay. So then after that, you will reach to B. So in B, after that, what are the neighbors of B you have?
E and F.
E and F.
F and A is also there, but A you have already visited. Hai?
Yes,
A
sir.
you have already visited. Then among A, E, F, A you have already visited. What are the options you are having? E and F. In E and F, which one comes first?
E.
E.
Now after that, in E, what are the neighbors you are having? B, L,
B, L, and J.
No. B, L, and J. No.
Yes, sir.
You have already visited B. So what are you are left with?
L and J.
L and J. Which one it should come?
J.
L. J.
J. Okay. Now in J, what are the neighbors you are having? E, K,
K and
and
M.
M. Among that, you have already visited E. So which one it will come first? In among K and M?
K, sir. K.
K. So K is there. Now after that, do you have anything? No. So it will go
No, sir.
back. So this is called reverse. You are reversing. Hai? You are going back and again you are choosing. So J is there. What are the options you have? You have already visited. E and K you have already visited. Now you have
M.
M. M. Again, do you have anything? Miss J you have already visited. So you cannot
No.
write again. So again you are going
Back
back
a
to its
step.
parent. Again, what are the neighbors you are having? J, E,
L.
K, and M. Did you visit E, K, and M already? E, K, M. E, K, and M you have already visited. E, K, and M. So again you cannot have. So you have to go to the previous parent of this one. Again E. What are the neighbors you are having? B, J, and L. Among that you have, which are the things you have visited? B and
B and
J.
J.
What are you left with?
L.
L.
Okay. Now L. What are the neighbors you are having? L,
E.
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 You have already visited. Again you cannot go. So you
Yes, sir.
have to come back again E. So in E you have visited all the neighbors.
Yes, sir.
Yes, sir.
Then you are going back to his parent.
B.
B. What are the neighbors he is having?
F.
A, E, and F. So you have, which are the nodes you have already visited?
A and E.
A and E.
You have now F.
F.
Now
Then G.
G. Again, G coming back F, and now
F
B.
to B, B to A to C.
Now A, and now again we have visited
C.
already B, then it will become
C.
C, then
D.
D, then
H.
I.
Then we stop, no? A to D.
after the D, no? D, what are the neighbors?
I.
No sir, H.
H, sir.
H, no?
H.
H.
H होगा.
Then I, no? H. Clear for a
Yes.
DFS? Anybody is having doubt now?
No sir.
Everybody is clear on this?
Yes sir.
Okay, now coming to DFS, how it works. Chalo. So in DFS, so can you see that before reaching to, okay, so the, before coming to that question, let us write for BFS. So in BFS, you have to write all the neighbors. So you have to, like, whatever the like branches you are having, you have to visit first all, then you move to the next. Like that it works. So I tell you. So A, what are the neighbors you are having?
B and C.
B and
B and
C.
C.
And next neighbor?
C.
E, F, D.
E, F,
E and F.
So next is B and C. Among B and C, what are the neighbors you are having? E, F, and D.
E, F, D.
E, F, and
E
D.
F D.
Then it will be when D. Then which are the E,
E,
F.
Then
F.
Then next,
Then A.
How A?
understand what I'm trying to do here? You are,
yes, sir.
G.
then what are the neighbors you are having? L, J, G, I, H.
G.
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 G
So you
H I
tell me.
L.
G, H, I, L.
G H I L.
G, H,
H
I,
L.
L, then
Sir, we don't
Then
have to write A in the starting.
A. Sorry, A I have to write now. Sorry. sorry. Yeah, A I have to write always. That is the
Sir,
origin.
first J will come, no? Before L.
Yes, sir. J.
J.
Sir, among these all 5, which one will come? Whatever you are saying, I'm writing. So
J.
So
J.
after H and I, there will be J before L.
yes sir, J
what should I
for
write
L.
here? So see,
J.
J
you understand
K
the
L M.
this is now it becomes all alphabetical after that. Anna? That is what I'm saying. So G, H, I, then
J
J,
J,
K
L,
L.
K sir. L M.
L, M,
After J, L is there.
L, and then M.
M.
K, M. M, K, sorry.
What?
So
So
after J, L is there.
L, why?
After J. This is a branch of
After
E, sir.
J, after J,
Sir, K is a branch of J, right?
Cannot be, sir,
No,
in
no.
between.
Yeah.
Before K, L should be there.
Yeah. Sorry. L should be coming
Because
before
this is a
that.
branch of E.
Yeah, correct. So see, among these guys, you have to tell that which are coming first according to your alphabetical sequence. Among that, this one alphabetical. Among this alphabetical. So what you are actually trying to do, you are just branches. First, you are exploring all the branches of this one. Whereas in case of DFS, one you are fixing, then you are going to the depth of that particular branch. If it is you have reached to the all the nodes, you are coming back to the parent, and then again. Sorry. Yeah. 1 second.
Hello.
Yeah, sorry. Yeah. So in DFS, what we are actually trying to do, you are going to the depth of the every branch. Whereas in case of BFS, you are reaching all the branches first, then you are reaching to the next level of branch. So I think in case of BFS, can you see the level wise you are reaching, means first level, second level, third level, fourth level, and fifth level? Can you see this, guys?
Yes, sir.
Yes, sir.
So now you got the answer for question number what? This guy. Now I think it is pretty clear for everything. No?
Yes, sir.
Anna? Yeah. So where I was, the main thing. So Yeah.
DFS.
So this is the DFS I was talking about. So in DFS, what it is given there means how it works. Now it will be clear. There was alphabets, nodes. Nodes are given alphabetical names, whereas here we have a integer data. So it's pretty clear. Means based on the magnitude, we have to write the first. If there is a coincide, means there is a like competition between two nodes, you are supposed to write which were coming the smaller, which are the smaller among the all. Okay, so where means this is the input graph you have. This is the graph you are having. This is very simple graph. Means earlier what you had, this is a little complicated. Sorry, no, not this. I will talk about this one. Yeah, this is like very complicated. So you have the more number of nodes. So where are you? Yeah. So this is the case. It is clear. My screen is visual, no, guys?
Yes, sir.
Yeah. Okay. So the starting nodes will be always given. Remember, a starting node will be always given. So first I'm trying to make you understand how DFS will work, which I have already explained through one of the example. But again, I'm trying to show for the integer named nodes. Okay. Then I will go for the actual DFS code. Okay, which sir has explained in one of the lecture. Okay, chalo. So a starting node is there. One is the starting node. Chalo, okay. One is there. So one will be the first origin. Okay. What are the nodes are connected with one?
2 and 4.
4, sir.
Even
2 and 4.
2 and 4 are
2
connected.
and 4.
So what is the, I'm just going to write the sequence. I mean, sequence. Do you understand what I'm talking about? Sequence.
Yes, sir. One after the other.
So how will be the sequence? Means let us say sequence
1, 2, 3, 4, 4.
Yeah.
1,
Sequence
2, 4.
Yeah. Sequence
1, 2, 3, 4,
so
5.
you are starting with one node. One is there. Then among 2 and 4, which are the coming first?
2. 2, sir.
So what are the neighbors of 2 you are having?
5 and
3 and 5.
3 and 5.
1 also.
3 neighbors are there. You are having. So see, in 1, which are the neighbors you had? 2 and 4. Okay. Among that, which are the smaller one? You have taken 2. Now the next one is 2. So with that, this you are also drawing the DFS tree. So among that 2, which are the neighbors you are having? 1, 3 and 5.
5 and 3.
But 1 you have already visited. Right?
Yes, sir.
Therefore, you have option for 3 and 5. Among 3 and 5, which are the smaller one?
3.
3. Okay? 3. Now 3, which are the neighbors of 3?
2, sir.
2, which you have already visited. Meaning, then you cannot go. What do you have to do? You have to go back to the parent of this guy. So 2 have reached. Now again you have to check what are the neighbors of 2 you are having. 1, 3 and 5.
1 and 5.
1, 3, 5.
Among 1, 3 and 5, you have already
1, 3 are visited.
Visited 1
1,
and
3 visited already. So next is
5.
5.
now we are coming to 5. And what are the neighbors of 5 you are having?
4 and 2.
And
4
4 and 2.
2.
And
2 and 4.
yeah.
2 and
So
4.
yeah. So
2 is
so-
visited. 4 is
2 already
remaining.
visited. So now it will be now 4.
4.
Now 4 is there. What are the neighbors of 4?
1 and
1
5.
and 5.
Did you visit
Both
all
are
the things?
visited.
Yes.
Already
Both are
visited.
visited.
So you will come back to the where?
1.
Parent of 4,
5.
which was 5. You have
5.
visited all neighbors of 5.
Yes, sir.
Then you will come back to the parent 2. You have visited which are the things? 1, 3 and 5 already. Now you
Yes,
come
sir.
here 1.
To
You
1.
have, so when you want to come to the origin, your depth first search procedure is over. Understand? So now I'm
Yes, sir.
giving you the one question. I mean here the starting node was what?
1.
1.
1.
Now a starting node is 5. Starting node is 5. Starting node
we
is
have to draw the
5.
graph.
And please. Starting node is 5. So everybody try to solve, and just I will ask from random numbers. Please do not write anywhere. If you have answer, please write it on your notebook and match whenever I'm revealing the answer. So I will ask randomly. So please make attention. So I started from 5 and try to write the sequence. Means what will be the sequence? For every one question is clear? Hello?
Yes, sir.
Okay.
Yes, sir.
Yeah, so please write when the starting node is what? 5 or the origin of this DFS tree is 5. Okay, chalo. 15 second I'm giving. 15 second is more than enough.
Yes, sir.
Chalo.
Yes, sir.
Yeah.
Done, sir.
Done, sir.
So I will call the random person.
Done, sir.
Yeah, Subrat Tiwari. Subrat Tiwari, can you hear me? Subrat?
Yes, sir. Yes, sir. 5, 2.
Yeah, okay. Yeah. 5,
4.
5, 2.
Sir, 5, 2, 1, 4.
1, 4 and
3, sir.
3. Janani? Janani? Can you hear me? Janani? Okay. Janani, can you hear me? Jagriti? Jagriti.
Hello.
Yeah, Jagriti, no? Who is talking?
Yes, I'm Jagruti.
Yeah, so is it clear? Means this is correct or?
Yes, sir. I think 52143 is correct.
Yeah. Yeah. For according to my, so everybody is clear and this is correct for everyone? Everybody got the
Yes,
same
sir.
answer?
Yes, sir.
Yes, sir.
Okay, good. Okay, so now coming back to the question. Something was very. Yeah, this is the question. I think the pseudo-code question. I mean, only the name of the variables are changed. Everything same. And this is already, I think, might have already. Soham had already discussed, I think, but still I'm trying to make you understand with little bit more in details. So you guys have already understood this part of the code, how it is working and all, or I mean, or should I explain? I mean, otherwise I can have another question.
Explain, sir.
Sir, please
Explain,
explain.
sir.
Explain, sir.
Sir, totally explain, sir.
Okay,
Sir,
chalo
please
then.
explain.
Yeah. So thing is that like first of all, try to understand what question you are asked. Okay. So you have like what is the value of s after executing the following pseudocode for I is equal to 2. So when I is equal to 2 is given, just understand that you have put 2 as the origin. Okay. Like in previous example, what I have told you, starting node. A starting node is nothing but origin of the code. And so you can see that P is equal to assigned, created as a empty dictionary. I tell you what it tells at the last, but just understand these are the defined. Some initialized value. I is equal to 2, so 2. So this is a dictionary. Initially you have initialize a dictionary, then P is with I is equal to 2, then 2 is a key and corresponding value is what? 1. So as soon as you have initialized, P is a dictionary with value 1. What is I is equal to 2? So 2 is 2. Well, it will look like this. I mean P will look like this. You have a dictionary with what is the key?
2 as a key and -1 as the value.
Yes. Meaning So
Okay, sir.
understand? So it will look like this.
Yeah.
And you have another list called S, and I tell you and what S will represent. S will represent something which you have already found out, but with the code you will understand that how S is related with this sequence. Both are same actually, I tell you, but this is written that is in this way, but this will be written. They will return like a list. And you have a 2p comma is and DFS is there. And how many parameters you have DFS? To call a procedure DFS, you have A, P, S, and I. Understand? A, P, S, and I. A you don't know, but I think somewhere you might have given. Yeah. So here is actually problem is from here. Yeah. A is actually a matrix. A is a matrix. And matrix of what? Which represents this guy. So A is a adjacency matrix. Adjacency matrix, meaning this A represents this graph. And what do you mean by it is representing this graph? So your A, actually this guy A is nothing but your matrix, and how it will look like. Means how many, just I need to put power. Can you see this? How many nodes are there in this? Can you tell me?
7 nodes.
7 nodes, sir.
7 nodes. So I mean it will be like this. 8 cross 8 I need to put. Yeah. So it will be like 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, and 6. Let me make it small so that it will be 0. So wherever why background noise is there? I think everybody have slept, but still I see background noise. Why? What is happening? Yeah. So A is there. Means matrix A represents this graph. So what do you mean by represents this graph? So wherever there is a connection, what it should be represented by 1. Otherwise
1.
0.
0.
0. So 0 is connected with 0.
That is 0, sir.
These all will be 0.
Diagonal element.
Diagonal elements will be 0.
Yes.
Principal diagonals, not so there are 2 diagonals, one this one and one this one, but I'm talking about principal diagonals. And principal diagonals are which elements? When I is equal to j, when value of I is same as j. Okay, that's how we will write aij, no, that like this, no, matrix is there, so this is I j, है ना? Okay.
Yes, sir.
One of the value will be represented like this. Okay. Chalo. So matrix A is there. So can you see 0 is connected with 1?
Yes, sir.
Yes, sir.
0 is connected with 1, 2, and 4. 1, 2,
2,
4, and
4,
5.
2, 4, 5.
So here it will be 0,
0.
0. 1 is connected with 0 and 3.
0 and 3.
3 is connected. This is. So do you think this is a symmetric matrix? This will be a symmetric matrix.
Yes, sir.
Yes, sir.
Symmetric matrix is what? Aij is same as Aj. Meaning if 0 is connected with 1, 1 is also
1 is
connected with 0, no? That is the physical meaning I'm talking about, symmetric matrix. If 0 is connected with 1, 1 is also connected with 0, no? If 0 is connected with 2, 2 is also connected with 0. Understood?
So that would be the case
So
of
there will be one.
undirected graph.
Yes. Yes. So that is
Click.
what also, if there is a no direction, I mean clicks. In case of
Yes.
click, that represents a symmetric
Undirected
matrix.
graph.
Yeah,
Symmetric.
undirected or symmetric matrix. ठीक है, चलो. Okay. Yeah. So 2 is connected with what? Only 0, no?
Yes, sir.
So sorry, this will be
Sir,
1.
1
and
is connected with 0, sir. So it should be 1 in the second.
yes. Yeah. So 0, 1, then 1, 0 should be also same value. That is the case symmetric matrix. Aij should be Aij. Okay. These things I think you guys already know. I mean from mathematics, है ना?
Yes, so like the mirror image of this one should be equal. Like both
Yeah,
must be
mirror
same.
image with respect to principal diagonal axis.
Yes, sir.
Is equal to 1.
No. It can be say 0, 3, then 3, 0 will be always 0. है ना? चलो. 1 is connected with 1 I have done. 2 only connected with 0. Rest of things will be 0. So did you understand what A will be there? Now it's clear. Should I write for everything?
No, sir.
Or
No,
you
sir.
understand?
No,
You
sir.
understood? ठीक है?
No.
Sir,
चलो. हाँ बोलो. Yeah.
sir, I forget. You only told or some other instructor that whenever there is a click, we can see that from adjacent matrix. Can you tell how that?
Whenever there is a symmetric matrix,
Whenever-
adjacency matrix,
Whenever there is a click, we can identify from adjacent matrix.
No. So adjacency matrix is like the matrix which represents a graph. That is called adjacency matrix. Symmetric matrix tells that is a click. Because if there is a connection, symmetric matrix is what? If Aij is same as Aj, meaning if 0 is connected with 2, then same time you can also say that 2 is connected with 0, no?
Yes,
If
sir.
author 2 has written book with author 2, then connection will be 0 to 2 will be also 1 and 2 to 0 will be also 1. है ना?
Sir,
Did I answer your question?
Yes, sir.
Okay. Tell me.
sir,
हाँ बोलो बोलो. Yeah. Tell me fast.
click
I have.
is everyone is connected.
Sorry.
Click is everyone is connected to everyone.
How many? Okay, so if there are n nodes, how many maximum nodes can?
Yes.
How many edges can be maximum possible?
N-1.
N into n minus 1 by
2.
Yes.
2. Remember? Yeah, it can be like, see, if there are 6, how many maximum this can have connections? 5. It cannot connected with the same, no? So there are 7, no, actually there are 7 nodes. So it can be, this can have maximum how many? 6.
6.
Sir, small doubts.
Yeah, please.
If 3 nodes are there,
Okay.
so everyone is connected to everyone, or
yeah,
it is
there
only
can be
ITC?
case, no? Everybody can be connected with everything. But that is what I'm
But
saying.
in
that
this
how many-
case, sir, 2 is not connected to 6,
yeah,
and 0 is not connected to 6.
It can be the case, no?
So is it a click?
This is no. So this a click of size. If I say that this is a represent, like if I say that this where is that? I tell you, it should have a click of generally. If I talk about click of size, generally we define click of size 1, 2, and 3. Like click of size 2, click of size 3. So there are 3 nodes in which every node should have 2 connections. Yeah, correct. Yeah. So yeah,
Everyone is connected to everyone.
Yeah. So I just make a little thank you. So I make a correction whatever I was told you. If there is a symmetric matrix, then definitely there is a undirected graph. But this undirected graph is a click that depends on the number of edges connected through the nodes. When if there is a n nodes are there, then there should have n into n minus 1 number of nodes. That can be only possible when every node is connected with every node, each and other remaining nodes. Here in that case, like
means here we required 21 nodes.
Yeah, means
For a
obviously the 7 is there, 7 into 6 divided by 2.
Yes.
So total 21 edges are required to make it a click of size
Or no,
7.
a click.
There is a small nodes is
Thank you,
a
sir.
small click is also not possible. I mean, if you consider the 0, 1, 3, and 4, but you can say 0 is not connected directly with 3. So obviously there is no click of size 4 also. There is no click of size 3 also. Can you see this? Understand? So
Sir,
remember
in a graph, if in this graph, sir,
yeah.
if in this graph, if one part is connected to everyone, say 0, 1, 3, and 4 is connected to each and everyone. Can we say this graph as a click?
Just give me a second. I think in some of the can someone tell me where is that problem where I was just some example is there? I mean, in this one also itself, I mean 11 itself.
I think it's in the starting.
Where is that? I will. I think these things I haven't talked about. Clicks and clicks. I think I have talked about. But tell me the where I have talked about. I mean, where you can say that. I mean, I don't remember where is that. Can anybody tell me where is that? This is a matrix actually. Real time connected to direct. Click of size. And you guys remember where is that? No.
No, sir.
So can you see this? This is the like. So how many nodes are there? This is another type of graph. How many nodes are there in this case? Like this is the case. How many nodes are there?
7.
15.
7.
1, 2, 3, 4, and total 7 nodes are there. So this is not a click of size 7, but you can say that there is a click of size 3. Can you say 0, 6, and 11? There is a click. 0, 6, and 12. 0, 6, and 14. Click of size 3. In 3 means if there are 3 nodes, there should be how many nodes or how many edges are required to make it click? N into n minus 1 number of edges should be there. So n is what? 3. 3 into 2 divided by 2. So how many edges are there? 1, 2, and 3. Yes. So therefore, it is fulfilling that condition. So this is a click of size 3, 0, 6, and 11. Same case, 0, 6, and 12. Understand? This is actually a click of size 3. But you cannot say this is a click of size more than 4. I think 4 is also not possible. No? 4 is also not there. Clear?
Yes, sir.
Okay, good. Yeah.
Thank you, sir.
Yeah, okay. Thank you actually. Yeah. Okay. Yeah, so when A is there, you have a matrix which represents this graph. Wherever connection is there, you have made it 1. Okay? Chalo. Oh, sorry. What happened? Yeah. So next is that as soon as you have called this guy, as soon as you have, it's clear, no? My screen is visual. So as soon as you have called with I is equal to 2, so P 2 is to 1, you have copied. Means I is equal to 2, so 2 minus 1. So your matrix will look like this. Can you see this? And S you have initialized as an empty list. And you have called A. A is what? That matrix, what you have created recently. This. Okay, clear? Since I have not completed, but you can understand that wherever there is a 1, there is a connection. And wherever 0 is there, there is no connection. That's clear? Okay.
Yes.
Now, as soon as if you see the DFS, you have input matrix. That P. Now P is what? This guy. And this one. Then S with the empty list. And I is what? 2. Clear? So as soon as you enter, what you have done, S is equal to S plus I. So what you have done, as you have entered, you have called this, now we have called this procedure, no? So as soon as you have called this procedure, you came here. Whatever the value you have called it, that will copy to this value, that matrix.
Sir, your voice is not clear, sir.
My voice is not clear.
It is right now.
Now it is clear. Now it is clear.
Okay. Yeah. Okay. So as soon as you have called this one, you have reached here. The value of A is copied. The same name is there. So therefore, no confusion. Value of P is what? This guy. S is this one. I is what? 2. So this is what it is written here. Okay? You are starting from here. This is your what? Node. Origin. So according to DFS, next will be what? It should be have
0.
Put the name as 0. So here it will come how I tell it. So S is equal to what? S plus I. What is the value of S initially? Empty. So as soon as you have called, it will be like S will become 2. S will have 2. Okay? Now J for each J in columns of A. So this is opening here where it has closed here. So inside it will be run for whenever one condition whenever the value of J you are starting with any value, like J is starting with 0, then it will go through each and every value up to this 4 lines, this 3 lines. Okay? Sure. So J is equal to 1 columns of A. So it will simply the number of columns 0 to what? 6 n minus 1. That is what? No, matrix. Where is matrix? This is your matrix. No? Till 6 it will go. It will start from 0. Okay? Sure. So J is equal to 0. So it will check if I is what? I is what?
I is row.
2, no? I is 2.
Yes, sir, 2.
So 2 and J is 0. So A
0
to 0 is
connected or not.
1. What it is actually checking, if there is a connection between I and J,
is between.
Then if there is a connection, then this condition is becoming true. So what is the value of I you have? 2, and next the first value of J is what? 0. It will start with 0, no? So 0 is there. So 2 0. What is the value of A 2 0?
1.
You can directly see here now because there is a connection. There should be value 1, and you can see that I is 2 and J is 0. So 2 0. What is the value of A 2 0?
Sir, please explain one more time, sir, from that procedure.
Chalo, ठीक है.
Sorry, sir.
Yeah, this procedure is there. So till here it is clear. The value of A you have input, P you have input this one, S you have input this one. Okay? S you have input this one. I is what? 2. That's clear. You have, as soon as you have called, means you have called with this value. Hai na? See, A is what? This Aij. P is what? This guy. S is what? This one. And can you see my cursor is moving whenever I'm speaking? Others?
Yes,
sir.
Yes, sir.
Yes, sir.
See, then
Yes, sir.
what is that? I is 2, no? Okay?
Yes, sir.
That is what I have written. So, chalo. So you have called this guy procedure. So where you should go? You should go to the procedure, no? Yeah. So we came to the procedure. And as soon as if you enter, what you have done? You have made it S is equal to S plus I. So S is what? Initially empty. Plus I is what? 2. You have 2. So you have made it S is 2. That's clear? Now,
Yes, sir.
or in J is equal to J in columns of A. So obviously it will start from J from where? 0 to?
Iterating through column of A.
Columns of
0.
A. So till when? 0 to 6?
6.
Hai na?
Yes,
So
sir.
when it is going first time, J will be what? 0.
0.
Now coming here. So what is the value of Y you have?
2.
2. So A 2 0. A 2 0. A
2 0
2
and 0.
0. What is the value we have?
1
1.
So your code will read from here, but you can directly understand that 820 there is a connection. So
Yes, sir.
obviously the value will be 1, but your pseudo code or the computer will not understand this one. You should make him understand by this one matrix. That is what we have already drawn. So this is the adjacency matrix which represents a graph. That is what we have done, nothing extra. To more visualization, I'm trying to say here. That's clear till here?
Yes.
Yes, sir.
Chalo.
Yes, sir.
Now is key p comma j. What is the value of p here? This guy matrix. Sorry, dictionary. Is key. What it does is key. P
Checking the J is a key in dictionary P
yeah,
or not.
Yeah. So in a dictionary P, whether J is a key or not. If key is there, what it will return? True. If it is not a J is a key inside the dictionary P, what it will return?
True.
False.
But
Na?
here it is false.
No, wait. So what I'm asking, just answer. Yeah. So if it is a key, then it will return true, otherwise false. Chalo.
False.
So P is what? You have this one. J is what?
So,
J is
0,
what?
sir.
0, no?
0.
So 0. So 0 is the key.
No, sir.
No, sir.
No, sir.
What it will return?
False, sir.
False.
False.
Not false.
True.
True.
This
True
is
and
true.
true.
This is true. Connected
True.
with AND operator.
True, sir.
Will it go inside?
Yes, sir.
Yes. Will it
Yes,
go in?
sir.
Huh? Clear, no?
Yes.
Till here.
Yes, sir. Clear.
Yes, sir. Yes, sir.
Chalo. So
Sir,
when
but P is empty dictionary, na?
where is P is the empty dictionary?
Sir, in the code only.
This is the current value. It is written here. You have assigned here, no? Can you see this? Before
Yes.
reaching to this one, what you have done? You have updated dictionary with this value. That is what it is written here. Okay, but still there is no key. J is 0 is not a key inside dictionary P. Therefore, it returned false, not false, true. This is also true and true. It will go inside. What it will do? J is what? 0. I is what? I is what?
2.
2. So P0 is equal to 2. So you have created a key which is 0 and corresponding value is what?
2.
Value 2.
2.
So when J is equal to 2, what you have done? You have made it this guy. Your dictionary is like this, no? Clear or not?
Yes, sir.
Yes, sir.
Yes, sir.
Now come here. So P comma S. What is your P? This guy?
P the dictionary.
No. So this is the return final value. This is the assigning value. So this is P and S. In that you are assigning the return value now again. So can you come here? So this is the variable. Now come here. You are calling again DFS. So what do you think this is a recursion? You are calling same procedure within itself. Don't confuse with this one because this is a typical type of procedure in which return values are 2. Can you see this? Also, whenever you are calling, the return values are 2. Can you see this? It has returned 2 values. That's why it is written here. So this is the return. So as soon as you come here, this you have to check here. So this is a variable, no, in which the return value of this one is assigned here. But what is this? This is DFS. Again, DFS will come here with the updated value of these things. So A is what now? A is still same. We haven't changed anything in A. Did we change anything? No.
No, sir.
What is the value of P you have? This guy. What is the value of S you have? This guy. And J is what? Tell me.
0.
0.
Clear? So you have called. So you have called this guy now. Can you see this?
Yes, sir.
This procedure was here as first one. Within that you have called this guy. Can you see this? So this is currently active now. So now again, as soon as you have come here, again A is, P is now this one, S is this one, I is this one. Again, as soon as you enter here, S will become S plus plus I. I is what? I is what?
0.
0.
0. 0. So S will become what? 2, 0. You have just appended one integer data, which is I 0. Till here, any doubt?
No,
No,
sir.
sir.
Everybody is clear on this? Chalo.
Yes.
Now, as soon as you come here, again, you are going first. Yeah. What's your name? Tell me first.
I am Hussain.
Yeah, and tell me.
How I become 0?
Why I became 0? That is what you are asking?
Yes, sir.
You have called this guy. This guy you have called, no? With this one.
Yes,
so
sir.
as you have called, the value of this will be copied to here. P will become P. This S will become this, which is the updated value in previous slide. So yeah, just me.
J become I.
And J is what? J become I, no? I will be J. And what was the value of J you had here?
0.
0, na?
So it become. Okay, sir. Thank you.
Okay, chalo. Okay, so you have called, and again you have called, then S is becoming 2, 0. You have appended with the current I value. I is what? 0. Clear? Chalo. Now you are going first time. First time you are going, no? For this case. Guys. True?
Yes, sir.
Yes, sir.
Yeah. So J, again it will start from J is equal to what? 0. J will start from 0, no? When you are going first time, again it will start from where?
Yes, sir.
0. Chalo. 0 is there. Now it will check. So I is 0, J is 0. What is the value of A 0, 0?
0.
So not
No connection. No, you can see from here, or just if you do not want to do, it will like 0, 0.
No corrections.
So it will not go inside. It will not go inside because no need to check this one. Why? Because this is connected with AND operator, and this itself is becoming 0. Sorry, this itself is becoming false. No need to check this condition. Agree, everyone?
Yes, sir.
Yes, sir.
Chalo, theek hai. Now J will become next what? 1. Agree or not? Next
Yes, sir.
J will be 1, no?
Yes,
now A01. What is the value of A01?
1.
1. Also you can see here 0. 1 is value is what? 1. Agree?
Yes, sir.
Yes, sir.
What is the
Yes,
value
sir.
of J here? 1. Now not is key P. P is what? You have till P is this one, no? So P comma 1. 1 is key in dictionary P or not?
False. No.
Huh?
No,
Not
sir.
the
No, sir.
No.
No. So what it will return?
false.
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 Not false?
True.
True.
Will it go inside?
Yes, sir.
Yes, sir.
Yes. What it will do? P 1 is equal to 0. Can you see this? So this will become, this is true. So this will become now this one. That we have updated this one, no?
Yes, sir.
Till once we update, the P will become like this.
Yes, sir.
So
Yes.
can you see this? What it is happening here in case of S and P and S? So firstly we will see S. So earlier when I told you that S will store, there is a sequence of the nodes how you have gone through in case of DFS. When it is true, next will be what? 0. Hana? I mean,
Yes, sir.
I just one next step I will tell you. Leave it. Only 2 is the, 2 elements are there, so it will be hardly it. Chalo, okay. When this till here it is clear. Now coming here with now again, as soon as if you call, This is again called here with updated value. Age is still same. P is now changed. P is updated with 1 is to 0. So P is this one. Ace is also updated. J is what? Tell me now. J is what?
1.
1, na?
Yes.
1. So as soon as you called 1, again it will come here with the I will be 1. Now I is 1, no? Guys.
Yes,
The value of J will be copied to I, no? So I is equal to J. J is 1. Now again come here. A is this one, okay? So as soon as you come here, you have updated the value of S.
Yes, yeah.
Okay? You have updated the value of S. Now J will start from again. This loop will start from where?
0.
J value 0. Now I is what? 1, no?
1.
1 0. What is that? 1 0?
1 0 1.
1 0.
Connected.
1 0 is connected, no? 1 0.
Yes.
Yes, sir.
1. So this is
But we
true.
have already visited.
This is true. And is key P comma J. What is P? P is there. J. J is what? 0. 0 is the key in this dictionary.
Yes.
Sir.
Yes.
So what it will return?
True.
True.
False.
Not true?
False.
It will not go inside. So what do you think that even though this is true, but so this tells that neighbors, connections, but this tells that whether you have visited or not. If you have visited, you are not going to go update. You are not going to inside. Can you see this?
Yes, sir.
Hannah. So what you see that S you have first like beginning, like 2 was the your origin. Neighbors are 0. So obviously it's direct. Only one neighbor is there. 2 0. What are the neighbors you are having? 1 4 and 5 2. 1 4 5 and 2. What? The first one comes which one? 1. 1 is there. You have to check for another also, but I'm telling that you have already updated. 1 is there. Hannah? So this tells the sequence. Next, what do you think it should come in this case?
3.
1 is
3.
3 should come, Hannah?
Yes, sir.
Okay, so S is that sequence is just storing. What is P is actually doing?
Marking the visited ones.
Marking the visited means this tells the combination of parent-child pair. Which is parent? Parent is this one and this is your child. Like origin is there, so that's why origin is 2, so there is no any parent. Means there is a like automatically it has generated like that event consider. So that's why this unexistent something quantity. This is your parent corresponding. Next
Excuse
for
me,
this
sir.
one, yeah, this is your parent. Through that 0 is. This is your parent. This is your. Can you this? So what is 2 to 0? You have it. So what is the parent for this one? 2, no? Can you see this?
Yes,
So 1, what is the parent through which it has come?
0.
Can you see this?
Sir, does sequence matter in this one?
Which one?
In P?
No. But it is a sequence in dictionary. It is not mattering, no? Doesn't matter. But it tells that like it's combination like 0. This one.
The combination is important, not the sequence.
That is the case of dictionary, no? Sequence doesn't matter, but this is important. This one. Because first you have visited 2, then 0,
Yes,
then
sir.
1. Anna. So next case I just tell you. So where I have reached. So I have updated the value of I, which is 1 now coming.
So just a small doubt.
Chalo,
Sir, sir, in every iteration you are revising the value of J equal to 0, but we have not completed that iteration now. We have not completed all the columns A, all the
while returning back we will do. First that is what we generally do in DFS. What we do, firstly we explore the depth. We do not spread we do not first look at the neighbors. We look at going to the depth of one of the branch.
So we can directly, if we are taking in the first iteration J as 0, then in the second iteration we can directly take J as 1. Why are we taking J again 0 and
with
then
the zero, these are the neighbors, but these are the neighbors 1, 2, 4, 5. Now I have to look at the neighbors, not like I have to check that all the 0, 1, 2, 3, 4, all the values. We have to look at the only the neighbors. Among the neighbors, whichever the smaller, you have to fix that one. Then this neighbor you have to check. You are not supposed to check with like 0 is there, then you have to look at 1, 2, 3, 4, 5, 6. Once you fix next node you are going, again it will start with the 0, means it is checking the neighbors. Connections are there. You are keep going like that. You are exploring the depth, not the branch. You are keep going. So this is like what you have done. 2 is there, connection is there among neighbors, which are the smaller 1. Now you will not further go for the j is equal to j is equal to 2. You have fixed, that's why you have called this guy. So as soon as you have called, this is becoming your fixed node, and now you are exploring this neighbor. As soon as you come here, then this will be fixed. Because of calling this one is becoming your fixed node. Now we are exploring the neighbor through this one. If it is visited, then you are not supposed to go inside. It will go to the next value neighbor. It will check whether other neighbors are also there or not. So that is what I was trying to explain in next step. But did you understand what I was trying to say here? No? Yes.
Just a little, sir. You can continue in the further steps. I can understand.
Yes. Yeah, it's not easy, but if you pay a little bit attention, you will understand. Sorry. Yeah. So where I was, I have updated the value j is equal to 1, j is equal to 0. I mean 1, 0. What I have done? I have updated. So 0 was actually the key already there, so it will not go inside. No, na. Then next j will be what? 1. So again 1, 1. There is no meaning. I mean obviously it will be 0. Anna? 1, 1 will be 0. No.
Yes, sir.
Yes, sir.
Now next j will be what? 2.
2.
2 is there again. I was just still 1, j is 2. A1, 2 is what? Connection is there or not?
No, 0.
Value will be 0. So you are not going to check further, such as no meaning, because this is now j will be again 3.
3.
So j 3. Now check 1, 3. The value of A1, 3 will be what?
1.
Because connection is there, and also you just confirm A1, 3. 1, Hannah? So
Yes,
1
sir. Yes, sir.
is true. Now check. P is what? This guy. Comma 3. ठीक है ना? Connection is 3. 3 is a key in dictionary P or not? No. What it will return?
False.
False. Not false? True. Overall true. What it will go? It will update the value P3. What is the value of I? 1. So this is your child and this is your parent. I mean, can you see this? This is your fixed. Through
sir.
this you are trying to explore. No, this was fixed and you are exploring. So this is there. Now again, A is this one, same A. P is what? Now P is this one. A is this one. J is what? Tell me. J will be now
3.
3, no? Now J is 3. As soon as you call for 3, now it will become I became 3 now.
Yes.
Yes, sir.
Now again you have called this guy, and again same thing. As soon as you enter, you will update the value of S with 2013. ठीक है? चलो.
Yes, sir.
213 is there. Now again J will start from where? 0, 1, 2. tip. So
Four.
chalo.
Four.
Now you understand that how this one and this one is working. So it will start, J will 0. So 3 0. Obviously it will be 0. 3 1. Connection is there, but 3 is key in dictionary P or not?
Yes.
Yes, sir.
What it will do? It will return false. This sorry, this will be return true, not true, false. It will not go inside.
Yes.
Next J will be what?
1.
2.
2.
J will be 2, no?
Yes, sir. 2.
So 2 is there. Oh, A 1 2. Connection is there.
No.
Then next J is what? I just keep writing. Then it will be. Next J is what?
3.
3.
3. There is no meaning 3 3 because I is 3, no? I is
Yes,
3.
sir.
So there is
J.
no meaning. Now J is become 4.
4.
Now 3 4. Connection is there.
Yes, sir.
Yes.
Yes, sir.
And 4. P comma 4. 4 is key in this dictionary P.
No.
No.
It will return false, not false.
True.
True.
It will go inside, and what it will do?
4.
It will do, no?
Yes, sir.
Yes.
And now again you are, so you have P is this one. Now come here. Again you have called J is becoming what? 4. Now you have called this I will become 4.
4.
Hana? So you are going through the depth, not through the branches. Now again you have called this one. Again you have updated 4 is there, connection. You have updated with S is 4. Now can you see this? 4 for the 4, let us see. 4 is there. For any value of J, for 0 there will be connection is there, but this will be overall false for when J is equal to 0. So when J is equal to 1, obviously this is false. Hana?
Yes, sir.
For none of the value, this both condition are returning overall true. Agree? Because for the 4, for the 4, G 0, 1 and 3, that all are already present in the dictionary P. Although this is becoming true, but this is becoming overall false. Hana? For 0, 1, 2, 0, 1 and 3, value of this will be true, no? Agree, no? But
yes, sir.
But this will be false, no?
Yes, sir.
Yes, sir.
So for any case, do you think it will go?
No.
No. So what you will do? You will suspend now this one. So it will go. So can you see this? Do you think, are you going to stop this iteration? This stop procedure? No, because this one you have called from where? Here. So
How
are
is
you
it going back?
see? Understood? So this one is now suspended. Hana?
By which code, sir? Which line is suspending this?
For all value of J,
yes, sir. Okay.
It is not true. So it will not go. So it will not go means it will return PS, which is coming here. I mean, as soon so this is the previous step, no? But these are still active. These things haven't closed. Can you see this? These are still active. Now you haven't explored for all values. This was still active. So you have stopped here for this case when J, then when I was what 4 and for all values of J, this condition none of that true. For that case, it has returned P comma S, which is this and this.
So after returning P comma
after
S,
returning it will come
it
here.
will stop the procedure.
No. It will come here. I mean,
return function works like that now only.
So what actually doing? So remember, so what when this was your member, what you have done? I mean, 4 you have reached here. What are the members you have? 0, 1, 3. All you have visited, Anna.
Yes,
what
sir.
you are doing actually, you are going back to the parent, no?
Yes, sir.
Because
Yes,
what
sir.
you're doing. Guys, remember or not?
Yes, sir.
Yes, sir.
We remember that in DFS this happens.
So
But
you are
by which code?
no, you are not stopping, and that is also not stopping here because this is the stopping this step, but this step is called from where?
The previous one, the when
The
J was
previous-
3.
From the previous one, no?
Yes, sir.
Right.
Yes, sir.
Yes, sir.
So
Yes,
this
sir.
stop, but now this is active now. Huh? For this case, I is equal to 3. Anna?
Yes, sir.
Now I is equal to 3. Then again it will check for the next value of, so where, for what value here J was there? Do you remember what was the value?
I value 3.
1.
Huh?
1.
4, no? For 4 you have,
4.
Yes.
so J will become now 5, no?
Yes.
Yes, sir.
So guys, who are doubted here? So in 4 you have been came inside and you have called this guy, and this one has returned this value P and S, which came here, and it will continue from there itself, no?
Yes, sir.
Guys, so this is little bit tricky, understand? So yep,
Sir.
read there.
So we done with DFS A, P, comma S, comma 4. So 4 will not go further. Then how we come back to this step? DFS A, P, S.
This is there. This one is okay. Just a minute. When for this case, are you able to? For this case, you are not able to do anything. Are you able to go inside for any one of the case?
So we are not able to do that.
So this one was.
Sir, your voice is
Voice is
or
not clear.
Guys, listen, give me a second. Just
Come to the mic, please.
if you speak, then how will you talk? So for that, then for this case, when I was 4, and
Sir,
for
voice
The
is not
voice
coming.
is fluctuating.
This is disturbing.
can you speak or you want to discuss?
no, your voice is not clear. That's why we are telling that only.
My voice is not clear.
So
Now
now
it
it's
is
clear.
Now
That's
it's
Oh,
Yeah.
now it is clear.
Yeah. So I mean, what I was telling, when I was 4, and for none of the value of J, this both condition was becoming true. Therefore, it will not go inside. It will return here. But this was called from where? This guy, no? So the return value of this one will come here. It will not stop the iteration. I mean, it will not stop the procedure, this one, recursive procedure, because this one is called from here, no?
Yes.
If all things are active, still active. You haven't suspended. Only this one was suspended because for none of the case, this is becoming true, this overall. Therefore, you didn't go. So you have returned this one, P and S, which came here now with the updated value. Now, when you have called for this one, that time P and S was different. Now we have updated and you have came here, return back here with the updated value P and S, whatever it is. Now come here. So none of the things were updated.
So return P, comma S is also a recursive process.
No, the return value is not a recursive procedure. No, so this return value will where it will go, from where it is called. I mean, see,
Just previous.
from where it is called, this one previous case, from here, no.
Yes.
Okay.
So it will go to the same step, no, same. See, you have called someone from Mumbai, then it will go to Mumbai only, no, it will not stop, no. Like that, you have called this one from here. Say once all cases are all work you have done, if it is there is a recursive, then again you are keep going like this, like that you are going. But since all work you have done, means none of the case it was there, You came here and you return the value, which return value will stored here. And now this will be again active because you haven't done for all the cases here. So now when, so till J was 4, you have active, Anna, because 3 to 4 connection was there. Now it came here, you have suspended because there none of the cases are true for J. When I was 4, you have a stop for this case, you return this one, but this return value will come here. It will not stop the recursive procedure. Aryan?
Yes, sir.
Understood. So
Yes, sir.
now,
Yes.
now again J will start from where? 5, na? Because 4 you have already done.
Yes,
J, again it will start from 5. Again it will check. I is what? 3. I is 3. J is
5.
Connection is there?
Yes.
Yes.
And 5 is the key inside dictionary P.
No, sir.
What it will return?
True.
False.
False.
Whole will return
False.
false.
Overall true. What
Yes.
it will do?
Yes.
It will
Yes,
update
sir.
the value with 5:3 and 5:3. As soon as you will call, what you will do? You will call this J is equal to 5 now. Aryan,
Yes,
is
sir.
it interesting?
Yes, sir.
Now you understood what is happening here?
Yes, I understood.
Okay, now 5 is there again. Now 5 is there. So again it will come. A is this one, S is this one, and I is what? 5 now. Okay? 5 is there. Again it will update the I with S with I, which is 5. J will start from where again?
0, 1, 2, 3.
0, 1, 2, 3, 4, 5. So again, when J will become 6, because see, previous for J is equal to 0, connection is there, but this will be false because 0 is already a
Key.
key. 1, there is no connection. 2, no connection. 3, connection is there, but there is a key.
Yes, sir.
4, no connection. 5 is no meaning. 6 is 5, 6. So A is 5. A56 value is 1 from this guy. A56 connection is there. So 1. Also 6 is not a
Key.
inside. So what is overall? This both will be true. Overall true. It will go inside. What it will do? It will update the value of dictionary P with 6 as a child, parent. Who is the parent? Clear? Chalo.
Yes, sir.
Again you have called this guy. So this is all operated. T, A is still same. P and A. What is the value of J here? Tell me. 6, na?
6.
So can you see this? This is still active. Hana? Guys, Aryan?
Yes, sir. Yes, sir.
Now again you have to call this
Check
guy.
for 6.
6 is there. Again you have updated 6. Now J will start from where?
0.
0. Do you think it will be true for any case?
No, sir.
One condition will be true, but
Suspended.
other will false.
So where it will go actually? Here, no? Return value will come here.
Yes, sir.
5, na?
5.
Now 5 is there. Again you will check. Again 5 is suspended because again you will start from J is equal to 6. 6, 6, 5, 6 connection is there, but you have already explored. No. So you have a suspended. This you have now you will suspend this one. So this was called from where? This guy, no? So now this one is there. Like that it will, from where it is called, that you have to remember, like that. So this procedure will work like this. So finally, what value you will have? So remember, do you remember, like when you had, I told you it will start from 2. So next will be what? 0. 0 is, neighbors are what? 1, 4, 5, and 2. Which are the smallest one? So you have already visited 2. So next will be
1.
1. 1 is there. Next, what are the neighbors of 1 you have?
0 and 3.
0, 4,
0, 3
0,
and
3.
4. You have visited 1. 0 you have already visited. Which one I was talking about? Sorry, 3 na? Yeah.
3.
I was talking about 3. Yeah. So what are the neighbors you have? 1, 4 and 5. No, sorry. 1, 4, 5. Did I miss any node?
So yes, we were talking about 1.
Okay, let us start from beginning. Chalo. So 2 was the
Yes, sir,
origin.
we understood that.
And now I'm trying to make you understand how it will work. Like 2 is the name, 2 is the origin. 1, 0, which is the child. Sorry, which is the parent? 2. 1 for next will be 1. So this order it can be anything, but the combination will be always unique.
Parent child.
If 3 1 is there, then 1 will be the parent and 3 will be your child. You can see this. 4 3 is there, then 3 will be your
Parent.
your
4 will be child.
5 3 is there, then 3 will be your
Parent.
Can you see this?
Yes, sir.
So like that it will
Excuse
be.
me, sir.
Uh-huh.
Sir, as in this case, like the value of key in this dictionary is the parent.
No. It is representing that child's, no? I mean the
Sorry,
key
yeah.
child, no?
Yes, sir, it is child. So can we change it like from the starting only? Can we keep the parent as the key number and the child as the value for it?
No. So this is that what is that technique we are using? Why do you want to change? Any reason? Specific reason?
No, sir, no specific reason. Like just for
This is
just
the
for
like
relating.
method we are following. That like you are starting from 2, which is the origin. For that you have
Okay, sir.
-1, like that. 2 is the origin.
Understood, sir.
Okay. So this is the more of a DFS. If I tell you now, if I tell you 4 is the origin, what will be the value? Tell me. Just
Sir, one question.
Please.
Sir, in the code, what is the base condition to terminate the recursive call?
So here base condition you have visited all the case. So when this was the case, no, when you have visited all the condition, at that time what was the returning value? P, S without DFS. Can you see that you haven't called? At that time it was
don't have neighbor also. That time also we call the same statement, right?
Sorry, repeat.
Like if there is no neighbor for a particular node, that time also we call the same statement, right?
The same, yeah, same thing. So this is actually checking both things. Now this is checking your neighbors and this is checking that you have visited or not. If that is the case, both are true, then you have to explore further neighbors. If no neighbors are there, obviously then it will be false. You will return the base value.
Yes, sir. But how the
value will return to the previous, not it will stop the process. It will stop the from where it is called. Remember, Hannah? That is what it happened. That is what it has happened.
All other parent nodes still active. So once we have no other nodes to explore, all other get okay.
Yes. Like that it happened here. No, because this was 4 was this was there, but no, nothing was there. All things for this case you have explored all these things. So what do you think? This will return. This will not go inside. No, what was it was returning? P, S. And P, S from where it is called, it remembers. No, so this is called from here. So this return value will come here, and from where it will again restarting. I mean restarting. No, J was actually 3. Then it will be like 4. Now 4 is you have checked. Then 5, 6 like that. So you always remember from where it is called. It will not come and stop overall. It will reach to the where you have called. Okay.
Thank you, sir.
Yeah. So one question, last question, and we are stopping. Then we will have a tomorrow. If or day after tomorrow. I will check with the team when is that free slot is there. If you have a origin is 4, tell me the sequence you have visited.
10, 0.
No one, I'm just random. I will ask if origin. Origin means I'm writing in this now in this way. If you have P is equal to P 4 is equal to -1. So this tells that you have origin is what? 4. Then what is the value of S you will have? Do you want to write also P? So P is 4 is to -1. Yeah, S will be what? I will ask randomly. Hey, it's already 12:30. Sorry. No, it's a 12:15 or something. Okay. Everybody got it?
Yes, sir.
How do you pronounce this name? Sthipanjana. Jena? Jena is
Yes.
there. How do you pronounce?
Sir, what?
Someone name is ending with the surname is Jena. How do you pronounce this name? Or I don't know. Yeah. Pratham Agrawal. Are you ready? Means, did you complete? What is?
Yes, sir.
Tell me the sequence.
So like 4, then 0.
Okay. Then
1.
Sorry. 0. Then
1. 3.
3.
5.
5.
6.
6.
And 2.
Okay. Ronak. Did you get the same?
Yes, sir. Same.
Pushpita.
Yes, sir. Same.
Okay. Do you want to write P also? Do you want to write? Yeah, P will be what? Tell me. So origin is this one, P. Then next parent and child is what?
0.
0.
0.
And parent is 4.
Parent is 2.
4. 4.
Next
4.
is
Sir, 4.
Sir, 4.
Parent is 4.
So we started from 4. So it will
2
be
is
4.
parent for 0, no? Did I?
We started from 4, sir.
Sir, 4 will be the parent of 0.
Huh?
Mm.
It's
You
correct.
have taken, no, you have taken example as starting from 4.
I have started from 4, no? Oh,
Yes,
sorry.
sir.
Oh, sorry. Yeah.
Yes.
Yeah. So I have started from 4, then
0, 4, sir.
0 and 4.
4. Yeah. Next is what?
1.
1 and 0.
1, 0.
1, 0. Yes. Sir.
So it will be
1, 0.
1,
1,
0.
0.
then
3, 1.
3, 1.
3, 1.
3 is the child, 1 is the parent.
Parent.
5,
5,
3.
5. So 5, 3, no?
5, 3.
Next,
6,
6,
5.
5.
5.
5.
6 is the child and 5 is the
Parent.
parent. Next,
2,
6.
0.
0.
2, 0.
the
0. 0.
0, 0.
Yes, sir.
correct?
2,
Everyone?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, then. So what I do, I stop for a now and then I will continue with the questions. So check out the questions, whatever you have, make a note and come up with the doubts tomorrow or day after tomorrow. Mostly the session will be daytime. If I'm getting slots tomorrow, good. If no, then mostly on Sunday. Okay?
Okay, sir.
Yeah.
Yes.
Thanks a lot, sir.
Thank you, sir.
Thank you, sir.
Thank you so
Good night,
much, sir.
sir.
Yeah.
Good night, sir.
Sorry
night,
for
sir.
the late sessions. I mean, I
No,
don't know.
sir, no problem, sir.
No, sir.
No,
No issue, sir.
Okay, somewhat clear now, DFS and recursion?
Yes, sir.
Yes, sir. Yes, sir.
It was very much required this session.
Question was very good.
Yeah.
Yes, sir.
Thank you.
Sir,
Huh.
sir, I have a doubt from graded assignment 10.
I will do it tomorrow. I mean,
Okay, sir.
yeah,
Sir,
because
actually, I
clear,
assumed.
uh-huh.
Okay.
Yeah,
Actually, I
what's the
assumed a.
pronunciation of your name? Jaina.
Yes, sir. Sthit Pragya Jaina.
Sthit Pranjana.
Yeah, it is Pragya.
Pragya. Okay.
Yes, sir.
Oh, nice name. I mean, I never heard. Okay.
Sir, actually, I assumed a case there where it is my answer is not matching with any one of the option. It is, I mean, according to me, the entire code
Is it graded assignment question?
Yes, sir. Graded assignment 10. So,
okay, so 10 I will clear tomorrow. Don't worry. But everybody, so that's why I told everybody. I mean, I promised that I will not take questions today. I will definitely do it tomorrow, so that others can be also cleared if they are having doubt in the same question. Okay.
Okay, sir. Thank you.
Yeah.
Thank you so much, sir.
Thank you guys for joining, and good
Yes,
night.
sir.
Good night, sir.
Good night, sir.
Yes, sir.
Thank you, sir.
Yeah. Thank you. Now I don't know where it went, how to stop the session.